Hello friends, hello and welcome to another session of Pulley System. In today's video, we shall discuss about tension and acceleration in string. The string which is moved over the pulley. So in that string, what would be tension and acceleration in different combination? In earlier video, I had explained for the very basic pulley system what is the tension and acceleration in that pulley system. Let me take a somewhat tedious topic, a somewhat tedious combination of pulley. So let's suppose it is the inclined plane. Now this time we are taking the inclined plane. Let this is the inclined plane. There is a pulley attached to this inclined plane, and a weight is hanged over with this pulley. Let this weight is having mass m2, then certainly its weight would be m2g, and this string is attached with another mass which is lying over this inclined plane. Let this is, it is having a mass of m1 mass. This is an inclined plane which is inclined at an angle theta. This is inclined at an angle theta. So this is the string. This end of a string is pulled by m2g force, which is the weight of this m2 block, and here this side it is also being pulled with the force that m1 block is applying on this string. I cannot say it is m1g because this force would be different. If it would have been in the directly suspended in air, then I could say it was m1g as it was in the earlier section of pulley, but it is in inclined plane. So this force would not be m1g, this force would be somewhat different. What the force would be? Let us calculate and find out the acceleration and tension of this system, pulley system. Suppose m2 is greater than m1. m2 is greater than m1. So this force is more. Number one, there would be tension T. There would be some tension T in the string. Since the string is same string and is a constant motion, so this would be tension T. This segment of string would also having the tension T. Since this force is more, so it will experience a acceleration A. This will experience an acceleration A, and the system will move in this direction, downward direction, with some acceleration A. Now find out what would be this force by which is this segment of string is being pulled with the mass m1. See, this is the center of mass. This is m1g. This is m1g cos theta. This angle is theta, and this is m1g sin theta. And the normal reaction that this plank will apply on the mass m, that would be equal to this normal reaction would be equal to m1g cos theta. I hope it is clear. Show this way. This is. So now we can say this string is being pulled downward with the force m2g and being pulled in this way, means upward with the force m1g sin theta. m1g sin theta. We cannot say it is m1g. It is m1g sin theta, and sin theta can never be greater than 1. So always remember, whenever a weight is on an inclined plane or on an inclined plane, its force of pulling would be less than m1g. Always remember, m1g would be always less than m1g sin theta. Very simple thing. m1g sin theta would be less than or equal to m1g. It cannot be greater than m1g. It may be, at the most it may be equal to. Otherwise it is lesser than the m1g. So we have to find out two quantities: tension in string and acceleration in string. These are the two quantities that we need to find. So to find these two quantities, we need two equations to solve them. Let us take this one. Here m2g is downward force and T is upward tension, and the system is going down. It means m2g is greater than T. So we can relate m2g minus T equal to ma. M is m2g and a is its acceleration. So m2g force downward, T force upward. The force difference is m2g minus T, and this force difference would create an acceleration a to the mass m2, which is equal to m2a. This is equation 1. Now come to this portion. This is being pulled upward. It means tension is more as compared to m1g sin theta. It means T minus m1g sin theta is equal to acceleration to this object. This object is having mass m1 and this is equal to m1a. This is equation 2. Simple. T is larger force because this block is being pulled up. So T minus downward force m1g sin theta is equal to mass into acceleration. Mass is m1 and acceleration is a. This is the acceleration a to this system. So this is equation 2. Adding equation 1 and 2. Adding equation 1 and 2. What we get? T and T would be cancelled out. So we shall have m2g minus m1g sin theta is equal to m2a plus m1a, or we can say a equal to m2 minus m1 sin theta into g upon m2 plus m1. This is acceleration of the system. In earlier case it was m2 minus m1 upon m2 plus m1 g, but in this case it is m2 minus m1 sin theta. This is the acceleration of the system. Now let us find out the tension. So put this value of a in any one. We are putting it T minus m1g, T minus m1g sin theta equal to m1a, or T equal to m1g sin theta plus m1, put the value of a, m2 minus m1 sin theta, g upon m2 plus m1. Take the LCM to add. LCM would be m2 plus m1. So this would be m1g sin theta into m2 plus m1, and this would be m1 m2 minus m1 sin theta g. Solve them. T equal to multiply m1 m2 g sin theta plus m1 square g sin theta plus m1 m2g minus m1 square g sin theta upon m2 plus m1. Now m1 square g sin theta, m1 square g sin theta, one is positive, other is negative. In addition, they would be cancelled out. So we get t equal to m1 m2 g sin theta plus m1 m2 g upon m2 plus m1. Yes, just make it rather compact. Bring out m1 m2g outside, so we get m1 m2 1 plus sin theta g upon m2 plus m1. So this would be t. So in simple pulley it was twice m1 m2 upon m2 plus m1g, but in this case in place of 2 we have to keep 1 plus sin theta. In simple pulley system it was twice m1 m2, but here it is 1 plus sin theta. Otherwise the same, this is tension and this is acceleration. Again, tension upon acceleration would be constant, T upon A, m1 m2 1 plus sin theta g m2 plus m1 A, cross multiply m2 plus m1 upon m2 minus m1 sin theta g. This would be cancelled out, g would be cancelled out. We can say m1 m2 and sin theta, since theta is constant, this is constant, m2 minus m1 sin theta again constant, so we can say t upon A is constant. T upon A is constant. Similarly, t into A is also a constant. So we can use any of the relation, either t upon A or t into A is a constant. These relations will be used in solving some numerical problems in pulley systems. I hope this is clear. There should not be any doubt. In my next video, I shall take another complicated example and then find out the tension and acceleration in that particular system. If you like this video, you please subscribe my channel so that whenever I upload a new video, you would be intimated. So keep watching my videos. You would be more and more entertained as well as with the knowledge. More and more entertainment with knowledge. So prepare for your competitive examinations. Watch the videos and learn a lot. Thank you. Thank you very much.